In developing economies, the agricultural sector often provides employment to many. Farming is also important for food security. Due to transportation problems, most of the harvest is for local consumption. In general, the agricultural sector remains underdeveloped. Farming depends on manual labor and hinges on poor techniques. Many risks such as diseases, droughts, inundations, threaten the agriculture. All in all, a bleak picture with low incomes and many risks. Access to finance could remedy part of these problems. Investing in better seeds, fertilizer, equipment, and irrigation would help. Also, insurance is helpful. It could cover unforeseen costs and protect against natural disasters. Regular commercial and industry banks will not reach out to the farming communities. Even the microfinance institutions focus on the cities and neglect the countryside. In the agricultural value cycle, low liquidity coincides with the peak in risk. Farmers invest in seeds, fertilizer at the start of the production cycle. Income becomes available after the crop harvest. Expenses to support the family tend to be of a constant nature. Risk exposure for droughts, heavy rainfall, crop diseases occur during the production phase. In the picture we see the agricultural value chain. We start with buying the inputs such as seeds and fertilizers. The farmer spends a lot. During the production phase he draws down his savings. There is no income yet. Risk increases with the possibility of droughts, diseases, floodings, etc. As the produce reaches the processing plants and markets, the farmer gets his income. His risk exposure decreases. For financial institutions, this is not an attractive proposition. Most farmers have no access to finance despite agriculture's local economic importance. This keeps farmers locked in a poverty trap. No access to finance prevents farmers from investing in productivity and risk mitigation. They remain exposed to risk. Farmers tend to prefer low-risk, low-yield strategies. These strategies keep them unattractive to financial institutions, hence, no access to finance. This takes us to the banking paradox. Risk is the financial industry's core business. Financial institutions specialize in dealing with risk. Portfolio techniques, insurance, and sophisticated financial instruments help banks in dealing with risk. They can mitigate, transfer, and manage risk. What is more, the bank's business models make money from slicing and dicing risk. So, why would banks avoid the risks in the agricultural sector? If we can describe, measure, and categorize farming risk in a professional way, we will be open for business in the agricultural sector. An important piece of the answer lies in the Argos Agricola Analyser (AAA) approach. Let us dive into this. The Argos Agricola Analyser (AAA) is a powerful tool to assist financial institutions. It assesses credit risk on a farmer level, as well as on a portfolio level, using a practical, hands-on method. The Argos Agricola Analyser approach follows simple principles. 1. Assessing a farmer's creditworthiness by predicting the cash flows. We do both, so incoming and outgoing cash flows. 2. The cash flows follow generic, standardized data of crop yields and prices. This circumvents elaborate questionnaires aimed at grasping the farmer's financial situation. 3. We model the uncertainty surrounding these parameters with probability distributions. 4. The probabilistic approach allows for running Monte Carlo simulations. The simulation result will reveal the expected default rates. It also expresses the risk in standard deviations. And it shows interesting breakdowns of the risk drivers. In this video we will zoom in on these principles. Before we move on, let us explain the name Agricola. Agricola is the Latin word for farmer. The farmer's cash flows are a good predictor of financial stability. We try to forecast future cash flows. We distinguish the revenues or incoming cash flow, and the expenses or outgoing cash flow. In our example, the blue line represents the incoming cash flow. The orange line is the outgoing cash flow. As long as the blue line stays above the orange line, the farmer is in good financial shape. The distance between the lines is an indicator of financial strength. The wider the gap, the better. the chance the farmer will default on his financial obligations is small. The inputs we use for cash flow forecasting are uncertain. Crop yields and market prices may vary. Expenses might be higher than expected, and so on. The question is how to cater for this uncertainty. Probabilistic modeling is the answer. We take the input variables and model them using probability distributions. For example, we look at the local market price for a produce. Often a farmer can tell you what price he anticipates to get for his crop. Also, he has a feel for the minimum and maximum price. So, our farmer has an idea of the expected price, the worst-case scenario, and the best-case scenario. These three inputs allow us to model a triangular distribution. In our example, we have the following values. The likeliest price is around 20. The minimum price is 15. This is worst-case scenario. The maximum price, or best-case scenario, is 30. These three values determine the shape of the triangle. The likeliest value defines the top, the minimum and maximum the left and right corners. A probability distribution shows the relationship between the possible outcomes, in our case the price, and the probability of these prices. The crop market prices are mapped along the horizontal axis. The vertical axis shows the probability. The higher the graph, the higher the probability. We notice that market prices around 20 are much more likely than prices in the left and right-hand corners of the distribution. It is possible to use other probability distributions. To keep things simple, we limit ourselves to the triangular distribution. For the incoming cash flow, we model the following inputs. Annual crop yield measured in kilograms per hectare. Expected annual market price measured in monetary units. Multiplying these inputs gives us the annual income of the produce. We do this for all crops. The sum results in the annual farming income. Notice that the farmer only must list the crops he tills and the surface of arable land to determine the annual income. Simple like that. We follow a similar approach for the outgoing cash flow. Here we consider the family composition and the annual costs for a typical adult, child, and senior person. Again, we use the triangular distribution to model the uncertainty around the anticipated costs. Now we are set for the Monte Carlo simulation. The essence of a Monte Carlo simulation is that we generate random values for the model input variables. The probability distribution governs this process. As the input parameters change each trial, the calculated cash flows will change as well. In a simulation session, we can run, for instance, 5,000 trials. With the variations in the inputs, also the calculated cash flows will vary. You could say that the simulation allows the farmer to live 5,000 virtual lives. We are foremost interested in the distance between the incoming and outgoing cash flows. A simple subtraction provides this margin. Margin is equal to the incoming cash flow minus the outgoing cash flow. Let's take a look at an Excel example. You can see that we define three blocks: revenues, surface area, and expenses. These elements allow us to calculate the incoming cash flow. The revenues are the sum of the multiplications of the yield, times the price, times the surface. In Excel, we can do this using the sum product formula. Next, the expenses. Here we assume a family composition of 2 adults, 2 children and 1 senior. The expenses are calculated using the sum formula. The margin available is the difference between the revenues and expense. We map the results in a histogram for further analysis. We group the financial margins in buckets or bins. We see those along the horizontal axis. The vertical axis shows the frequency. The higher the graph, the more a margin bracket occurs. This frequency translates into a probability. The more frequent a margin bracket, the more probable this outcome is. Let's take a look. Firstly, we see that the mean or average of these 5,000 trials equals to rounded 1,545. This differs from the base case calculated in Excel using the expected revenues and costs without the minimum and maximum scenarios. This variation in the input variables has an effect on the simulated average. The base case, however, amounts to 3,050. The single-point Excel calculation gives a too optimistic view on the cash flows. The probabilistic model produces an average that is more realistic. This method integrates the risk surrounding cash flows. Financial institutions gain much from this approach. The second observation pertains to the spread of the data. If the results are clustered around the middle, there would be little risk. We can then assume that the future farmer income is close to the average. On the other hand, with observations scattered over a wide range, there would be much risk. Trials could vary and the results could jump up and down. The statistical measure for the spread of the data is the standard deviation. A low standard deviation means little risk, a high standard deviation much risk. Thanks to the Monte Carlo simulation, we can quantify the risk. A third advantage is that we can identify the risk drivers. The various input parameters differ in their contributions to the risk. A sensitivity chart identifies the main risk factors. Looking at the chart, we see that the biggest contributor risk is the wheat yield. This is useful information for both the farmer and the financial institution. All measures that mitigate the risk surrounding the wheat yield have a big impact. They will improve the farmer's risk profile and income. This information translates to concrete measures such as investing in fertilizer, irrigation, flood protection, tools and equipment. The financial institution can play a role here. We also notice that the expenses associated with a senior person living with farmer pose a high risk. This is due to increased health risk and the expenses for a possible funeral. Again, the financial institution can play a role. Insurance would help to mitigate these risks. The Monte Carlo approach also helps decision-making. Risk in itself is not stopping financial institutions from lending. After all, they are in the business of risk-taking. Financial institutions make these decisions in line with their risk policies. The Monte Carlo approach allows us to do just that. Putting a marker at the margin value 0 splits the graph in two parts. The red part shows the negative consolidated cash flows. The blue part the positive cash flows. Since the surface of the graph represents 100%, we can assign percentages to the different color parts. We see that the area in blue equals rounded 98%. We can conclude that we are 98% certain that the farmer's cash flow margin is higher than 0. The red part equals 2%. So, there is a 2% probability to end up with a negative margin. Using this approach, a financial institution can set a threshold that expresses its risk appetite. Say, a financial institution's risk policy requires a 90% certainty level. In other words, the institution wants to be 90% sure that there is a positive consolidated cash flow. We notice that at a 90% certainty level there is a corresponding cash flow of 1036. We find this amount by looking at the cutoff threshold at the 10th percentile. The area in blue covers, hence, 90%. In other words, we are 90% sure the farmer's cash flow will be 1036 or more. From this we learn that the farmer has the capacity to pay 1036 for reimbursements and interest payments. This is helpful when deciding on a loan request. There is one more advantage of the Monte Carlo approach to discuss here. The farmer's cash flows and their standard deviations allow for portfolio optimization. As you may know, a clever portfolio composition leads to a reduction of the overall risk. So, the overall portfolio risk is smaller than the sum of the individual credit risks. Financial institutions can steer their loan origination process and favor loan demands that would mitigate the overall portfolio risk. We created a special video on optimizing loan portfolios. With this solid knowledge on Monte Carlo simulations under our belts, we return to the Argos Agricola Analyser or AAA. The Argos Agricola Analyser is an online solution that runs on a central server. The application can be part of a larger loan origination system. Another option is to run it as a separate module and let the solution interface with the loan origination system. The Argos Agricola Analyser simplifies the data input. Many crops and their yields are already present in the system. These statistics are based on the United Nations FAO data. They are specific for each country. It is possible to add and define data for certain regions. We apply the triangular distribution. Finding the minimum and maximum is relatively simple. Defining the top of the triangle requires some flexibility. Strictly spoken, this top is the mode, or the value that occurs most frequently. With limited datasets, this mode is hard to define. A practical approach is to replace the mode with the average, or the average of the last 3 data points. We use a similar approach to capture the costs. On the one hand, we have the farming costs, on the other hand, the family expenses. The system provides ample freedom to define these categories. Now, we just capture for the incoming cash flow the farmer's crops and the surface of the parcels for each crop. This could be done using Google Maps. Here you can draw the lots and the corresponding surface is calculated. Multiplying the yields and the surface results in the end in an incoming cash flow. For the outgoing cash flows, we capture the family composition. We apply the standard cost per family member and age bracket. Thus, we define the expenses. With these simple inputs, we are ready to run the simulation. The simulation gives us 5,000 results. It is as if the farmer can live his life 5,000 times. The Monte Carlo approach provides valuable information. We see the average margin that we can expect. We can measure the standard deviation. We see the main risk drivers and we see how much money we could lend out given our institution's risk appetite. We conclude that the Argos Agricola Analyser is an excellent tool to help financial institutions in lending to the agricultural sector. The AAA simplifies the work of the credit officers. Also, the tool lifts the documentation burden off the farmers. Moreover, the AAA provides superior insights in the risk associated with the loan application. This way, financial institutions can make better lending decisions in line with their risk policies. The Argos Agricola Analyser helps banks and microfinance institutions to better deal with the complicated but important market of agri-lending. Good luck!